Welcome to the I Can't Sleep podcast, where I help you drift off one fact at a time. I'm your host, Benjamin Boster, and today's episode is about volcanoes. A volcano is a vent or fissure in the crust of a planetary mass object, such as Earth, that allows hot lava, volcanic ash, and gases to escape from a magma chamber below the surface. On Earth, volcanoes are most often found where tectonic plates are diverging or converging. And because most of Earth's plate boundaries are underwater, most volcanoes are found underwater. For example, a mid-ocean ridge, such as the Mid-Atlantic Ridge, has volcanoes caused by divergent tectonic plates, whereas the Pacific Ring of Fire has volcanoes caused by convergent tectonic plates. Volcanoes resulting from divergent tectonic activity are usually non-explosive, whereas those resulting from convergent tectonic activity cause violent eruptions. Volcanoes can also form where there is stretching and thinning of the crust plates, such as in the East African Rift, the Wells Gray Clearwater volcanic field, and the Rio Grande Rift in North America. Volcanism away from plate boundaries most likely arises from upwelling diapirs from the core mantle boundary, called mantle plumes, 3,000 kilometers deep within Earth. This results in hotspot volcanism or intraplate volcanism, in which the plume may cause thinning of the crust and result in a volcanic island chain due to the continuous movement of the tectonic plate, of which the Hawaiian hotspot is an example. Volcanoes are usually not created at transform tectonic boundaries, where two tectonic plates slide past one another. Volcanoes, based on their frequency of eruption or volcanism, are referred to as either active, dormant, or extinct. Active volcanoes have a history of volcanism and are likely to erupt again, while extinct ones are not capable of eruption at all, as they have no magma source. Dormant volcanoes have not erupted in a long time, generally accepted as since the start of the Holocene, about 12,000 years ago, but may erupt again. However, dormant volcanoes are technically considered to be seismically active. These categories are not entirely uniform. They may overlap for certain examples. Large eruptions can affect atmospheric temperature as ash and droplets of sulfuric acid obscure the sun and cool Earth's troposphere. Historically, large volcanic eruptions have been followed by volcanic winters, which have caused catastrophic famines. Other planets besides Earth have volcanoes. For example, volcanoes are very numerous on Venus. Mars has significant volcanoes. In 2009, a paper was published suggesting a new definition for the word volcano that includes processes such as cryovolcanism. It suggested that a volcano be defined as an opening on a planet or moon's surface from which magma as defined for that body and or magmatic gas is erupted. The word volcano originates from the early 17th century, derived from the Italian name Vulcano, a volcanic island in the Aeolian Islands of Italy, which in turn comes from the Latin name Volcanoes, referring to Vulcan, the god of fire in Roman mythology. The set of processes and phenomena involved in volcanic activity is called volcanism. The study of volcanism and volcanoes is called volcanology. According to the theory of plate tectonics, Earth's lithosphere, its rigid outer shell, is broken into 16 larger and several smaller plates. These move continuously at a slow pace due to convection in the underlying ductile mantle. And most volcanic activity on Earth takes place along plate boundaries, where plates are converging, and lithosphere is being destroyed, or are diverging, and new lithosphere is being created. During the development of geological theory, certain concepts that allowed the grouping of volcanoes in time, place, structure, and composition have developed that ultimately have had to be explained in the theory of plate tectonics. For example, some volcanoes are polygenetic with more than one period of activity during their history. Other volcanoes that become extinct after eruption, exactly once, are monogenetic, meaning one life. And such volcanoes are often grouped together in a geographical region. At the mid-ocean ridges, two tectonic plates diverge from one another as hot mantle rock creeps upwards beneath the thinned oceanic crust. The decrease of pressure in the rising mantle rock leads to adiabatic expansion and the partial melting of the rock, causing volcanism and creating new oceanic crust. Most divergent plate boundaries are at the bottom of the oceans, and so most volcanic activity on Earth is submarine, forming new seafloor. Black smokers, also known as deep sea vents, are evidence of this kind of volcanic activity. Where the mid-oceanic ridge is above sea level, volcanic islands are formed, such as Iceland. Subduction zones are places where two plates, usually an oceanic plate and a continental plate, collide. The oceanic plate subducts, dives beneath the continental plate, forming a deep ocean trench just offshore. In a process called flux melting, water released from the subducting plate lowers the melting temperature of the overlying mantle wedge, thus creating magma. This magma tends to be extremely viscous because of its high silica content, so it often does not reach the surface but cools and solidifies at depth. When it does reach the surface, however, a volcano is formed. Thus, subduction zones are bordered by chains of volcanoes called volcanic arcs. Typical examples are the volcanoes in the Pacific Ring of Fire, such as the Cascade volcanoes or the Japanese archipelago, or the eastern islands of Indonesia. Hotspots are volcanic areas thought to be formed by mantle plumes, which are hypothesized to be columns of hot material rising from the core mantle boundary. As with mid-ocean ridges, the rising mantle rock experiences decompression melting, which generates large volumes of magma. Because tectonic plates move across mantle plumes, each volcano becomes inactive as it drifts off the plume, and new volcanoes are created where the plate advances over the plume. The Hawaiian Islands are thought to have been formed in such a manner, as has the Snake River Plain, with the Yellowstone caldera being part of the North American plate currently above the Yellowstone hotspot. However, the mantle plume hypothesis has been questioned. Sustained upwelling of hot mantle rock can develop under the interior of a continent and lead to rifting. Early stages of rifting are characterized by flood basalts and may progress to the point where a tectonic plate is completely split. A divergent plate boundary then develops between the two halves of the split plate. However, rifting often fails to completely split the continental lithosphere, and failed rifts are characterized by volcanoes that erupt unusual alkali lava or carbonatites. Examples include the volcanoes of the East African Rift. A volcano needs a reservoir of molten magma, a conduit to allow magma to rise through the crust, and a vent to allow the magma to escape above the surface as lava. The erupted volcanic material, lava and tephra, that is deposited around the vent is known as a volcanic edifice, typically a volcanic cone or mountain. The most common perception of a volcano is of a conical mountain, spewing lava and poisonous gases from a crater at its summit. However, this describes just one of the many types of volcano. The features of volcanoes are varied. The structure and behavior of volcanoes depend on several factors. Some volcanoes have rugged peaks formed by lava domes, rather than a summit crater, while others have landscape features, such as massive plateaus. Vents that issue volcanic material and gases can develop anywhere on the landform and may give rise to smaller cones. Volcanic craters are not always at the top of a mountain or hill and may be filled with lakes. Some volcanoes can be low-relief landform features, with the potential to be hard to recognize as such and be obscured by geological processes. Other types of volcano include mud volcanoes, which are structures often not associated with known magmatic activity, and cryovolcanoes or ice volcanoes, particularly on some moons of Jupiter, Saturn, and Neptune. Active mud volcanoes tend to involve temperatures much lower than those of igneous volcanoes, except when the mud volcano is actually a vent of an igneous volcano. Volcanic fissure vents are generally found at diverging plate boundaries. They are flat, linear fractures through which basaltic lava emerges. These kinds of volcanoes are non-explosive, and the basaltic lava tends to have a low viscosity and solidifies slowly, leading to a gentle sloping basaltic lava plateau. They often relate or constitute shield volcanoes. Shield volcanoes, so named for their broad shield-like profiles, are formed by the eruption of low-viscosity basaltic or andesitic lava that can flow a great distance from a vent. They generally do not explode catastrophically, but are characterized by relatively gentle effusive eruptions. Since low viscosity magma is typically low in silica, shield volcanoes are more common in oceanic than continental settings. The Hawaiian volcanic chain is a series of shield cones, and they are common in Iceland as well. Olympus Mons, an extinct Martian shield volcano, is the largest known volcano in the solar system. Lava domes, also called dome volcanoes, have steep convex sides, built by slow eruptions of highly viscous lava, for example, rhyolite. They are sometimes formed within the crater of a previous volcanic eruption, as in the case of Mount St. Helens, but can also form independently, as in the case of Lassen Peak. Like stratovolcanoes, they can produce violent explosive eruptions, but the lava generally does not flow far from the originating vent. Cryptodomes are formed when viscous lava is forced upward, causing the surface to bulge. The 1980 eruption of Mount St. Helens was an example. Lava beneath the surface of the mountain created an upward bulge, which later collapsed down the north side of the mountain. Cinder cones result from eruptions of mostly small pieces of scoria and pyroclastics that build up around the vent. These can be relatively short-lived eruptions that produce a cone-shaped hill perhaps 30 to 40 meters high. Most cinder cones erupt only once, and some may be found in monogenetic volcanic fields. It may include other features that form when magma comes into contact with water, such as Mar explosion craters and tuff rings. Cinder cones may form as flank vents on larger volcanoes or occur on their own. Based on satellite images, it has been suggested that cinder cones might occur on other terrestrial bodies in the solar system too, on the surface of Mars and the Moon. Stratovolcanoes are tall conical mountains composed of lava flows and tephra in alternate layers, the strata that gives rise to their name. They are also known as composite volcanoes because they are created from multiple structures during different kinds of eruptions. The main conduit bringing magma to the surface branches into multiple secondary conduits and occasional laccoliths or sills. The branching conduits may form parasitic cones on the flanks of the main cone. Classic examples include Mount Fuji in Japan, Mayon volcano in the Philippines, and Mount Vesuvius and Stromboli in Italy. Ash produced by explosive eruption of stratovolcanoes has historically posed the greatest volcanic hazard to civilizations. The lavas of stratovolcanoes are higher in silica and therefore much more viscous than lavas from shield volcanoes. High silica lavas also tend to contain more dissolved gas. A supervolcano is defined as a volcano that has experienced one or more eruptions that produced over 1,000 cubic kilometers of volcanic deposits in a single explosive event. Such eruptions occur when a very large magma chamber full of gas-rich silicic magma is emptied into a catastrophic caldera-forming eruption. Ash flow tuffs emplaced by such eruptions are the only volcanic product with volumes rivaling those of flood basalts. Supervolcano eruptions, while the most dangerous type, are very rare. 4 are known from the last million years, and about 60 historical VEI-8 eruptions have been identified in the geologic record over millions of years. Volcanoes that, though large, are not large enough to be called supervolcanoes, may also form calderas, collapsed crater, in the same way. There may be active or dormant cones inside of the caldera or even a lake. Such lakes are called volcanogenic lakes, or simply volcanic lakes. Submarine volcanoes are common features of the ocean floor. Volcanic activity during the Holocene epoch has been documented at only 119 submarine volcanoes, but there may be more than 1 million geologically young submarine volcanoes on the ocean floor. In shallow water, active volcanoes disclose their presence by blasting steam and rocky debris high above the ocean's surface. In the deep ocean basins, the tremendous weight of the water prevents the explosive release of steam and gases. However, submarine eruptions can be detected by hydrophones and by the discoloration of water because of volcanic gases. Pillow lava is a common eruption product of submarine volcanoes and is characterized by thick sequences of discontinuous pillow-shaped masses which form underwater. Even large submarine eruptions may not disturb the ocean surface due to the rapid cooling effect and increased buoyancy in water as compared to air, which often causes volcanic vents to form steep pillars on the ocean floor. Hydrothermal vents are common near these volcanoes, and some support peculiar ecosystems based on chemotrophs feeding on dissolved minerals. Over time, the formations created by submarine volcanoes may become so large that they break the ocean's surface as new islands or floating pumice rafts. In May and June 2018, a multitude of seismic signals were detected by earthquake monitoring agencies all over the world. They took the form of unusual humming sounds, and some of the signals detected in November of that year had a duration of up to 20 minutes. An oceanographic research campaign in May 2019 showed that the previously mysterious humming noises were caused by the formation of a submarine volcano. Subglacial volcanoes develop underneath ice caps. They are made up of lava plateaus capping extensive pillow lavas and palagonite. These volcanoes are also called table mountains, tuyas, or in Iceland, mobergs. Very good examples of this type of volcano can be seen in Iceland and in British Columbia. The origin of the term comes from Tuya Butte, which is one of the several tuyas in the area of the Tuya River and Tuya Range in northern British Columbia. Tuya Butte was the first such landform analyzed, and so its name has entered the geological literature for this kind of volcanic formation. The Tuya Mountains Provincial Park was recently established to protect this unusual landscape, which lies north of Tuya Lake and south of the Jennings River near the boundary with the Yukon Territory. The material that is expelled in a volcanic eruption can be classified into three types. 1. Volcanic gases, a mixture made mostly of steam, carbon dioxide, and a sulfur compound, either sulfur dioxide, SO2, or hydrogen sulfide, H2S, depending on the temperature. 2. Lava, the name of magma when it emerges and flows over the surface. 3. Tephra, particles of solid material of all shapes and sizes, ejected and thrown through the air. The concentrations of different volcanic gases can vary considerably from one volcano to the next. Water vapor is typically the most abundant volcanic gas, followed by carbon dioxide and sulfur dioxide. Other principal volcanic gases include hydrogen sulfide, hydrogen chloride, and hydrogen fluoride. A large number of minor and trace gases are also found in volcanic emissions. For example, hydrogen, carbon monoxide, halocarbons, organic compounds, and volatile metal chlorides. The form and style of an eruption of a volcano is largely determined by the composition of the lava it erupts. The viscosity and the amount of dissolved gas are the most important characteristics of magma, and both are largely determined by the amount of silica in the magma. Magma rich in silica is much more viscous than silica-poor magma, and silica-rich magma also tends to contain more dissolved gases. Lava can be broadly classified into 4 different compositions. If the erupted magma contains a high percentage of silica, the lava is described as felsic. Felsic lavas are highly viscous and are erupted as domes or short, stubby flows. Because felsic magmas are so viscous, they tend to trap volatiles that are present, which leads to explosive volcanism. Pyroclastic flows are highly hazardous products of such volcanoes, since they hug the volcano's slopes and travel far from their vents during large eruptions. Temperatures as high as 850 degrees Celsius are known to occur in pyroclastic flows, which will incinerate everything flammable in their path, and thick layers of hot pyroclastic flow deposits can be laid down, often many meters thick. Alaska's Valley of 10,000 Smokes, formed by the eruption of Nova Rupture near Katmai in 1912, is an example of a thick pyroclastic flow or ignimbrite deposit. Volcanic ash that is light enough to erupt high into the Earth's atmosphere as an eruption column may travel hundreds of kilometers before it falls back to ground as a fallout tuff. Volcanic gases may remain in the stratosphere for years. If the erupted magma contains less than 52% and more than 45% silica, the lava is called mafic or basaltic. These lavas are usually hotter and much less viscous than felsic lavas. Mafic magmas are formed by partial melting of the dry mantle, with limited fractional crystallization of assimilation of crustal materials. Some erupted magmas contain less than 45% silica and produce ultramafic lava. Ultramafic flows are very rare. Indeed, very few have been erupted at Earth's surface since the Proterozoic, when the planet's heat flow was higher. They are, or were, the hottest lavas, and were probably more fluid than common mafic lavas, with a viscosity less than a tenth that of hot basalt magma.